Let's talk about the most complex, most powerful, and, most mysterious object in the entire known universe. And the wild thing is, it's that 3-pound organ sitting right inside your skull. This is kind of like a user's guide to you. And it all starts with a single, really shocking accident.
But first, let me ask you something. Really think about this. Is it even possible for one single event, one accident, to completely change who you are? Not just your memories, but your personality, your character, your very soul.
Well, for a guy named Phineas Gage, this wasn't just some philosophical question. Back in 1848, he was a railroad foreman, and an explosion sent a tamping iron, we're talking a metal rod over 3 feet long, clean through his head. And the craziest part, he lived. But the Phineas Gage who woke up, he just wasn't the same person. He was no longer Gage. Now, this absolutely shocking case turned out to be the first real clue that our personality, our decisions, the very essence of who we are, isn't some abstract thing. No, it's physically located right there in the brain, in specific spots that act as a command center for everything we are.
It took more than 100 years, but with modern tech, scientists were finally able to model Gage's skull and figure out the exact path that iron rod took. And it turns out the damage was pinpointed to the ventral medial frontal lobe. And today, we know that exact spot is absolutely critical for managing our emotions and making good decisions. Damage there literally changed Phineas Gage forever.
And Gage's injury, that was just one piece of this giant puzzle. If we zoom out a little, we see the brain is basically organized into 4 main parts, or lobes. Right up front, you've got the frontal lobe. That's your CEO making the big decisions. Behind that is the parietal lobe, which helps you make sense of the world. On the sides, the temporal lobe is handling everything you hear. And way in the back, the occipital lobe is your personal vision department.
But, and this is where it gets even cooler, the brain's organization is more fascinating than that. It's not just one big lump of tissue. It's actually split right down the middle. It's really a tale of 2 very distinct, highly specialized halves, and each one has its own unique way of seeing the world.
So that raises a pretty big question, doesn't it? If you've kind of got 2 different brains living in one skull, how on earth do they work together? How do they talk to each other to create the single, seamless experience of being you?
Well, this brings us to a really important idea called lateralization. And it's actually a pretty simple concept, but it's profound. It just means that the 2 halves of your brain, the 2 hemispheres, they aren't just mirror images. Nope. They each have their own special skills and their own jobs to do.
And this division of labor is incredibly clear. Your left hemisphere, well, that's usually the analytical one. It's handling things like logic, speech, and math. Meanwhile, your right hemisphere is more of the artist. It's great with spatial awareness, creativity, and music. And here's a fun little quirk. Each side of your brain controls the opposite side of your body.
So how do they work together? Well, they're connected by this incredible piece of biological hardware, the corpus callosum. The best way to think about it is like a superhighway of nerve fibers, a high-speed data bridge that lets the 2 halves share information almost instantly, making sure that you feel and act like one single whole person.
Okay, so we've seen the brain's big picture layout, the lobes, the 2 halves, that massive data bridge, but how does the information actually travel? For that, we need to zoom in. Way in, down to the microscopic level of the body's own electrical wiring. Because everything we've talked about so far, every single thought you've ever had, every memory, it's all built out of these things, neurons. These are the fundamental building blocks, the basic units of your entire nervous system, and you have billions of them, all firing away.
And here's how they talk to each other. It's a process called synaptic transmission. It all starts with a little electrical spark in one neuron. That spark zips down a long fiber called the axon until it reaches the end. When it gets there, it triggers the release of these tiny chemical messengers called neurotransmitters. Those chemicals then float across a tiny gap, the synapse, and get picked up by the next neuron, telling it, hey, your turn to fire. It's this incredible microscopic relay race happening billions of times every single second.
And here's the really crucial part. The type of chemical messenger matters a whole lot. For example, dopamine helps you pay attention. Serotonin plays a huge role in your mood. GABA kind of has a calming effect. And when these chemicals get out of balance, you really feel it. That's why, for instance, medications that help adjust serotonin levels can have such a huge impact for people dealing with depression. It's all about getting the chemistry right.
So, remember how we were talking about the two hemispheres and that corpus callosum bridge connecting them? What do you think would happen if you actually cut that bridge? Well, a small group of patients gave scientists a once-in-a-lifetime chance to find out, and it gave us some of the most powerful proof of how our brain is organized.
So back in the 1960s, there was this radical surgery for people with really severe epilepsy. To stop the seizures from spreading from one side of the brain to the other, surgeons would just cut the corpus callosum. For a researcher named Roger Sperry, this was an incredible, unique opportunity to see what happens when the two halves of the brain literally cannot talk to each other.
The experiment he designed was just brilliant. See, everything you see in your left field of vision goes to your right brain, and everything on the right goes to your left brain. So Sperry flashed a word just to the patient's left visual field. That meant the information went only to their nonverbal right hemisphere. The side of the brain that handles language, the left side, was completely in the dark.
And the result is just mind-blowing. When Sperry asked the patient what they saw, the patient, speaking from their left hemisphere, said, "I didn't see anything," and they weren't lying. But then their right hemisphere, which did see the word, could control their left hand and make it draw a picture of the object. I mean, think about that. It's like two separate consciousnesses in one head. It's absolutely fascinating.
The takeaway was just undeniable. Sperry's work was the ultimate proof that the two hemispheres have their own independent and distinct abilities. This whole left brain and right brain thing wasn't just some pop psychology idea anymore. It was a real, demonstrable scientific fact. So how in the world did we get here? This incredible level of understanding about our own minds, it didn't just pop into existence. No, it was built piece by painstaking piece over more than a century of shocking accidents, brilliant insights, and amazing new technologies. Every single discovery, from poor Phineas Gage all the way to Roger Sperry, was just one more step on this incredibly long journey. You have to remember, for most of human history, the brain was a complete black box. Studying a living one was just impossible. But slowly, a clearer and clearer picture began to emerge.
And this timeline just shows you that amazing progression. It really all kicks off in 1848 with that tragic but crucial clue from Phineas Gage. Then, decades later in 1924, we get the EEG, which let us listen in on the brain's electrical chatter for the very first time. By the 1950s, modern imaging like PET and MRI scans let us actually see inside a living brain. And all of that work paved the way for scientists like Sperry in 1968 to finally confirm the specialized roles of each half of the brain.
So from the brutal, accidental lesson of a single iron rod all the way to the incredible precision of modern brain imaging, we have slowly and methodically started to draw a map of the very thing that's doing the mapping, the organ that literally creates our reality. Which leaves us with one last, pretty profound thought. Every single thing you see, hear, and feel is constructed by this incredible machine. It builds your entire world from the inside out. So, what happens when the architect gets it wrong? What happens when our reality breaks?